Hey, how's it going, everybody? Welcome back to the next episode in this Labs CPP Labs for School episode where we're just going through all the labs. This is found, at this website. Look at the lab assignments. We're at the end of set 2. Apologize for the delay, just got a little sidetracked with other things, but I do intend on still going through all of these. Okay, so we left off from last episode. Let's see, we had finished 6, I believe. Yeah, looks like we finished 6 here. And I'm just gonna walk through them all from here. So that was 6, and I am using Windows to do this. This is a Cygwin. So this is essentially like a Linux environment. So if you're using Linux, it's great. If you're using Windows to follow along, you should be able to do so in Visual Studio, Community Edition, or with Cygwin and Visual Studio Code. Should essentially be the same. So the next set of questions in this lab is basically, what is the output of the program? So they just want a simple answer, and so you're supposed to walk through it and find out. So let's walk through these. So integer x equals 10, and another integer y is also being instantiated. And then the next line sets y equal to x plus plus. So this is a post increment, so y would become equal to 10. And then x after this is now 11. So y is 10. And there we go. And we could run the code, and I'm sure we'd get the same thing. Let's see. Let's look at the next one. This is exactly the same, except they're outputting the y, or the x. Sorry if I said those backwards. So same thing, instantiating x is 10 and a y, and setting y equal to x plus plus. So y becomes 10, x increments post or after, and then x will be 11 here. Now, the thing about this, well, I'll talk about it more in a second. There's something a little tricky about these, and also vague. Okay, so let's x equals 10, x plus plus. Now what's x? X is, of course, 11. And if we do this again, int x equals 10, and a y, and then we set y equal to the pre-increment of x. So x will increment here to 11, and then it will set to y, so y should also be 11. Yep, very good. Looks like we're seeing that according to the answer, so we're following it correctly. And now int x equals 10, and a cout of an increment of the x. So this should be 11 as well, since it's pre, and yes, it is 11. And this should be 10 over here because it's post. So while it does end up increasing it to 11 during this particular line, it's still going to be a 10. And now we get to number 8. This is a little trickier, and also I've done a little research on this subject, and it looks like there's no guaranteed order of operations on these. So these might be different in different compilers, just FYI, but apparently they're looking for a certain answer here in this lab. But yeah, since there's no guarantee of orders, I think there is in C++ standard 17 and beyond, there is a guaranteed order of operations. But anything older, there isn't. So that's what I found. I don't remember the source. I think I read it on some technical thing or C++, and it seemed accurate. So that's just a, yeah, that's where it comes from. So we set int x equal to 10, and then we have a y, and then we set y equal to x plus x plus plus. So this is going to be 10, and this is also going to be 10, and then x is going to increment afterwards. So we should get a y of 20, because it should just be 10 plus 10. Let's see if that's the case. No, it shows 21. So something a little different is going on here. I think well, like I said, it might be different on different compilers, but if someone knows an exact answer, you're welcome to tag this area of the video and leave a comment. But I think what happens here is it does this one, and while this evaluates to 10, it post increments, and then when it evaluates this one, it's 11. So it ends up being 10 plus 11. I'm guessing that's what's going on here, and then it's going to be a similar thing here on the second part of it. Same initialization, then y equals plus plus x, x plus plus, and x. So based on the findings of the last one, I would assume this would be 10 plus another 10, but now it has incremented to 11 and then plus 12. So 10 plus 10 plus 12, because let's see, it post incremented to 11 and then it pre-incremented to 12. So I would think y would be 32 here. Let's see if that's what they get. No, they get 35. So that's entirely different than what I calculated. And if someone knows the exact reasoning for it, because it doesn't seem like it adds up to me either. And yeah, when I studied up the subject, like I said, I basically found that there's no guaranteed order. You could get different results. Don't do this. This is kind of bad, not even just style, just bad consistency type programming. So that's what I found. Take that as what you will. And looks like we have one more, and it's a very similar thing, except it has these in a different order. So it assumes, I'm assuming question 8 is specifying that the order of these matters very distinctly, and supposedly it does on C++ 17. I'd have to do my own testing. But if we just take this, for example, and put it into our compiler, let's see what we get. It is this one right here. And we will go ahead and run this. Oopsie. Okay. So cd vars. Oh, I could bring this over so you guys could see it. I'm just going into the folder where this file is, and I'm going to run that make file. And we also get 35 in our compiler, so that's interesting. So I am apparently walking through this wrong. I'm not sure how exactly. Yeah, I'm really not sure why exactly, because in this one it seems to assume we go from right to left, but in this one it doesn't. So it's a little more all over the place, it seems like. Let's do one more assumption real quick. Let's say this is 11. Let's say this is an 11. This is a 12. That would equal 34. So we'll say this is an 11. This is a 12, and this is a 12. And that would equal 35. Is that what it's evaluating to? 11 plus 12 and then plus 10. Or another 12. Plus 11 plus 12 plus 12. Is it? That would add up to 35. But that doesn't make sense to me because, okay, this one's a pre-increment. Yeah, that makes sense. This one's a post. It should still be 11, right? I don't know. I don't understand the order there. But apparently I get the same thing here. So sorry for not knowing the exact answer, but hopefully we can shed some light on that based on further discussion later. Int x equals 10. Just doing the last one here. Int x equals 10. And then it's another situation, and let's just see what this one equals. I would think it would equal, I don't know, let's say 10 plus 11 plus 12. So 33. Yeah, that one does turn to 33. So maybe no matter where, well, maybe it really matters where this pre-increment one is. Still seems a little weird to me that they, I don't know, I'm going to plug this one in and see what it turns into now. Okay, I'm going to grab this. If I can, keeps wanting to grab the frame of the website. Put a standard there. And let's see if we get 33. Yeah, we do. Very good. Okay, so I'm just going to cat my make file here so you guys can see what it is. It's very simple. This is all it has in it. So it builds the program and runs it. You should already know that if you saw any of the previous episodes. What is the output of the following program? Okay, so this is a setw, which uses IO manip. So we'll get rid of this old code, and we'll say we're on to number 9. So setw basically sets the width of your console output, so you can line things up and make specific graphs with numbers right down a line and things like that. So it just helps you with formatting. And let's see what we get here, because it's going to push them all to the right. I'm just going to run make, and yeah, it pushes the starting digit at least to the width of 5. So it like sets the width of a column to 5. So you can see this 77 is got 3 spaces in front of it, is hundreds. So it starts the end of the number and fills to the left. Apparently it's how that works. So you could set 5 if you wanted a header to be right there, like something like, let's just call it some variable called gas. Just a random thing. And there's no run target on my make file. So now you can see it kind of looks like a little column. I don't know, that's usually what they're used for, but it could be for other things too. And this works just as well for outputting to files. What is the output of the following program? Float net equals this number. We say precision 2. So this changes something about how cout works. It sets the precision to 2. This sets the fixed point, I believe, setf on the cout. We're setting it to fixed and show point. So show point will show this decimal no matter what. Fixed, I don't remember what iOS fixed does. Let's have a look. So I can just search it on Google here, and you can always do the same if you're ever stuck on something, and we'll find out exactly what it does. Sets the float field format flag for the stream to fixed. When the float field is set to fixed, floating point values are written using fixed point notation. The value is represented with exactly as many digits in the decimal part specified by the precision field. Okay, so since we set the precision to 2, it's just going to say it's fixed to 2. And I think show point just always shows the point even if there's nothing to show. I could be wrong. Correct me if I'm wrong on that. Comments below. And as you can see, it just fixes at those 2 digits. So that's a way to sort of represent money with like a float or a double. But another pro tip, do not represent money with floats and doubles. It doesn't work because money only goes to 2 digits for the cents. And this is calculating beyond 2 digits. So you could get some oddities and end up with extra or missing money. So basically what you do is you use integers only instead and just count the number of them. Like 100 would be $1.00. And you just don't use decimals if you're actually working with money. So just FYI. Hope that makes sense. If not, ask for clarification below. Is that it? Did we finish this? We did. Okay, so we finished set 2. We'll start with set 3 in the next episode. Thank you for tuning in. Hope you learned a few things or at least got a refresher. And I hope you're all enjoying the new year. May the weather be good for you in your life, 2020. Let's do this. And if you're watching this in the future, welcome to the past. Peace out, guys. See you in the next episode.